In this video, we're going to talk about how to find concavity algebraically instead of just looking at a graph. To find concavity algebraically, we use a second derivative number line. So very similar to what we did in the last lesson in 4.4, but now we're doing a sign line with the second derivative instead of the first. Now, one side note right here. Most textbooks use open intervals for concavity. We will do the same. So let's start right here with example number 5 first. So it's very similar to what we did in the last lesson where we're going to find the derivative and find the sign line, the critical numbers, make a sign line, and test out numbers. So the only difference is we're going to find the critical numbers of the second derivative this time instead of the first derivative. So let's start by finding the second derivative. So the first derivative is going to be 4x cubed plus 3x squared minus 6x. And my second derivative is going to be 12x squared plus 6x minus 6. There we go. Now I need to find my critical numbers. So this is where f prime is 0 or undefined. So really quickly, this f double prime is a parabola. It's a quadratic, so there's nowhere where it's going to be undefined. So let's set it equal to 0. I have a GCF of 6. And now I can factor this out to 2x minus 1 and x plus 1, and then set my factors equal to 0, solve it out. So I get critical number of 1/2 and negative 1. So now I do my sign line. So on my sign line, I'm going to put my critical numbers. And now I'm going to start to test things out. So let's test out one over here. So let's say negative 2. Let's test out 1 in the middle. So let's say 0. And we'll test 1 to the right, say positive 1. And I'm testing these out in the second derivative, so plugging them into my second derivative. So first one would be this, which when I plug all that in, that's going to be a positive. Second one, let's plug in 0. When I plug all that in, that's a negative. And then let's plug in 1. When I plug that in, that's a positive. So now remember, this is no longer increasing and decreasing, this is concavity. So what this means, let's do pink and orange. So this positive means my smiley face, concave up. So there's my smiley face. This negative is my frowny face, concave down. And then I have another positive. That's going to be concave up again. Actually, let's use green. There we go, pink and green, that's pretty. So this is talking about concavity now. So I have concave up, concave down, concave up. Positive, negative, positive. So if I wanted to determine the concavity, I would say this is concave up from, let's see, negative infinity to negative 1, and from 1/2 to positive infinity. It's concave down from negative 1 to positive 1/2, and it says determine the points of inflection. So it looks like I'm going to have a point of inflection at -1 comma something and 1/2 comma something. So I'm going to have a point of inflection right there and right there. That's where I'm changing concavity from positive to negative and then from negative to positive. Now if I want to fill out what the rest of these are, then I need to plug them into my original function. So that would be -1 to the 4th plus -1 cubed minus 3 times -1 squared plus 1, which is going to be -2. And then I can plug in 1/2 to do the same thing. And that's going to give me 7/16. So there we go. That's your first example where we discuss concavity and find our points of inflection. Let's try one more. Let's try number 6. Now, they've already given you f double prime, so we don't need to find it. So we can just start right here at finding our critical numbers. I want you to pause the video and try to find the critical numbers on your own. Remember, it's where it equals 0 and where it's undefined. So you're going to set this equal to 0 and solve it, and undefined where the denominator equals 0 and solve it, and see if you can correctly find our critical numbers. Pause the video and try that out now. Welcome back. So if we set the whole thing equal to 0, solve it out, I would end up with x squared equals -4/3, which when I take the square root, that's the square root of a negative, so that's imaginary, so I don't have any there. Where it's undefined, set the denominator equal to 0, I solved that out and I got plus or minus 2. So my critical numbers are just plus or minus 2, so I started my sign line here. Now I want you to try to plug in the numbers. I'm just picking some. If you pick different ones, that's okay. You should end up with the same sign. Try plugging these into f double prime to get your signs. Try that out on your own. Pause the video and then come back and see if you did your sign line correctly. Welcome back. You should have gotten positive, negative, positive. So concave up, concave down, concave up. So I've listed my concave up and down intervals here. Now let's talk about the points of inflection. Now normally we would think, hey, point of inflection at -2 and +2. That's where it changes sign. Except one thing we need to remember. This -2 and +2 were not where it equals 0. This is where it's undefined. So this -2 and +2, because it's in the denominator, these are actually asymptotes. And remember, point inflection only exists if you can have a tangent line there. We can't draw a tangent line on an asymptote. So this problem actually does not have any points of inflection because those are asymptotes. They're not going to work. Okay, that's it for our algebraically concave up and down. In the next video, we'll talk about the second derivative test.